What happened? Okay. Week 10's new material that could be on the quiz, right? Where do we want to start? Let me look at my notes. We're going to start right here. Try to remember about a binomial. This is from week 3. This is why we're talking about it again, because we got to learn how to use the binomial table. Don't forget, how do you recognize a binomial problem? Let me give you this. Well, first, oh wait. Remember this formula? We're not reviewing how to solve it manually, but I want to show you that long formula from week 3 only had 3 numbers being used. The x was the number you're being asked about, which I call the first number right up here. That's your x. The n is how many random were in the random sample. And I call that, I got the wrong, hang on a minute. Darn it. Cross that out, you guys, fix your notes. I was going too fast. That's not the mean, that's the number in the sample. Number in sample. Number in sample. There we go. All right? That's your n, number in the trial. P is the given probability. Hey, we usually have 15% of this product, or we usually have 10% turnover, or whatever it is. That's the given probability. Those are the 3 numbers. And you just have to plug them in, the 3 numbers right here. You know what? I got the whole binomial formula wrong, don't I?
Isn't there a P?
Isn't there a P? Man, I'm telling you, I must have been daydreaming this morning.
Well, they're both supposed to be the opposite.
There we go, we'll fix it in a minute. Because we forgot P and everything on it. All right, but let's recognize it. Let's recognize it. Here we go. Evans is concerned about low retention rate for the employees. In recent years, management has seen a turnover at 10%. There's the given probability, so we'll start there. This one is 0.10. Matter of fact, I put 0.10 right there. Given. We'll jump to the next one. Choosing 3-hour employees at random. There is the number in trial 3, or how many were chosen at random. In this case, there was 3. Then it says, what's the probability that one of them will leave the company year? What number is being asked about? 1. So now, I guess I should have looked at the Excel equation. Let's open it up and look at it. Let's see, here we go. Let me bring up, this is the answer. I'm gonna do it right here in the answer to this one. Equals B-I-N-O-M. There it is right there. I'm gonna use the dot distribution right there, even though I don't have to use the dot. Here it is, number being asked about, how many are in the trial, what's the probability, then the 0, 1. Number being asked about, number in trial, I'll call it random, but that's all right. Trial, comma, the percent given, comma, 0 or 1. There it is. Number in trial, or selected at random, I call it, 0 or 1. There we go. So there's 4 numbers.
So
Yes.
for the first one, is this supposed to be the opposite of the number being asked?
If this is a more than, so if this question, let's go back to the question real quick. If this question says, what's the probability 1 or more of them, then we gotta use the opposite as the first number here. If it said 1 or more. If this said 1 or less, then we're gonna put just the 1 there being asked about. We're using this top equation. But we have a 1 on the end because it said or less. But in this case, this is asking about what's the probability of exactly 1 out of the 3 no longer being with us. Exactly 1. So in this case, we would have equals binomial dot distribution, parenthesis, what's being asked about? Probability of 1. How many randomly selected? 3. What's the given percentage? 0.10. And then, is this more than, less than, 0 or 1? 0, because it's asking for it exactly. There it is, to get the answer. Let's do this real quick. We'll put it in. This is reviewing the Excel. Equals binomial distribution. What's the probability of 1 out of how many randomly in the trial? 3. What's the probability? 0.10, comma, a 0 on the end, because it's asking for exactly 1. Our answer is 0.243. Let's look at the PowerPoint. 0.243, but now we gotta use the table. So let me give you some advice for the quiz. Make sure both the Poisson and that binomial table are downloaded off of Canvas and ready to go during the quiz. If we have a question about these tables on the quiz, I'm not giving you the table. You gotta have the table ready to go. So, let's go to the table. Again, what are our numbers? A 1, a 3, a 10%. 1, a 3, a 10%. You open the binomial table, it looks like this. Let me get to the top. Here we go. Across the top are all your P's, the given probabilities. So I'm gonna make sure I'm giving you a probability that's on this table if I have a table question. 1%, 5%, 10%, 15, 20, 25, 30, 35, all the way to 95. All right? So I'm not gonna give you 52.5%. It's not on this table. Gotta go. 10%, that's the given percentage right there. So we're gonna use the column underneath 10%. Now, the N is how many are in the trial in this particular case. On this table, the far left number is how many are in the trial. In our case, how many were selected at random? 3. So we're gonna go down to the 3, which is right there, where my pointer's at. Now the question says, what's the probability 1 will no longer be with us? It's not asking about 0, it's not asking about 2, it's not asking about 3, just 1. So we only have to write down this number. Now, how do you show work if this were a homework question or a quiz question? Because there's only one number there, this is very difficult to show work. But if this said 1 or less or 1 or more, I would be looking to see what numbers you used off the table and added them together. If you use the right numbers, that's your work. But in this case, there's only one number there. Let's look at what that one number is. 10%, 3 is in the trial, and then the 1. I'm going across right to the left of my pointer. 0.243, which here was 0.243, which here was 0.243. So you can see how this table works. There it is, 2.243, just to the left of my pointer.
Can we do more than?
Now, let's say this question said 1 or less. 1 or less. What numbers are you going to show me for work? Here we go. 1 or less. You're going to show me the work. 0.243 is the 1, but what else? What else are you going to show me? There it is, 0.729. 0.729. There's the work. You add them together. 7, 8, 9. This is, wow, really close to 100%. Oh, didn't have a calculator ready, and neither do you. Here we go. 0.243. 0.243 plus 0.729. 0.729 equals 0.927. 0.972 or 27?
72.
Thank you. 72. There it is. Quarter point, quarter point, quarter point. This is 3/4 of a point question. There's the work I need to see. What numbers did you use off the table? Let's pretend now this is 1 or more. 1 or more. We could go either direction on this table. We could find the opposite of 1 or more and subtract it from 100%, or we could just add up all the numbers that represent 1 or more. Either way, whatever's easiest for you. So 1 or more, I'm going to put my pointer, again, we're at 10%. We're at 3 in the trial, but 1 or more, there's 1.243. So let's say now it's 0.243 plus what's below it, 0.027, is that what it says? 0.027, what's below that? 0.001. So that's for number 1, that's for number 2, that's for number 3. For 1 or more, we add all those together.
So just those 3 numbers?
Just those 3, because 1 or more would include the 1, the 2, and the 3, right? Go ahead, Christine.
So let's use that 2 or more. Can we do 1 or less?
You can do 1 or less and subtract it from 1, or you could do 2 or more. Absolutely, Valerie.
Well, gee, it's the same about.
Same question? Let's do a bigger one. Let's do a bigger one. You ready? Let's do a bigger one.
Yes.
Same question?
The algorithm is for
How come you're gonna add the whole, row or column?
Well, how come I didn't what?
Why didn't you add all the numbers down?
I didn't include 0 because for 1 or more, you'd only have 1, 2, and 3.
No.
Oh, below that?
Yeah.
Oh, below that represents if we had 4 in the trial. It represents if we had 4 in the trial. Below that's if we had 5, but we only have 3 in the trial, so we can only use these numbers right here. Right there.
We not use 2 and 1.
What do you mean not use 2? Oh, up above here?
Yeah.
Oh, because if there was only 2 in the trial, then we would use these numbers up here. You've gotta line up this end.
But the or less doesn't
The,
carry
the or less only represents the numbers in that, however many are in that trial.
Understood?
Yeah, so here we go. We're gonna do this again. This will make more sense. I'm gonna change all these numbers. Ready? This time, we're at a different company. And they usually have, I gotta pick a percent that's on this chart. They usually have more like 15% turnover. There's their usual, okay? They want to do a bigger trial, so they picked more employees. Matter of fact, they went ahead and picked 5 employees at random. And they're asking, what's the probability to be 2 or less no longer with us at the end of a year? There it is, 2 or less. Hit me with the binomial first. What's the first number in the Excel? 2, because 2 or less, comma. How many are in the trial?
5.
5. What percent as
15.
given? 0.15. And what's the last number?
0. I mean 1.
Because 2 or less. Because 2 or less. You gotta put a 1 on the end. There's our Excel. Now let's use this. We're gonna use the column with 15%, which is right where my pointer's at right now. There's 50%. I'm gonna make this bigger. Let's get this bigger. Whoa, whoa, again. Okay, there's the 15%, but I gotta go all the way down where there's 5 in the trial. I can't use the numbers here where there's 4. I can't use the numbers here where there's 3. Can't use the numbers where there's 2. I gotta go down to where there's 5. Now, which column are we in? 1, 2, the third one over, fourth one over. I'm in the 4th column over, right where the pointer is. It starts with 0.444. So let me scroll up a little. Okay, here's the column we're in. Now this says, what's the probability of 2 or less? You're taking this is a homework problem or a quiz problem. You're asked to use a table. You're asked about the question about 2 or less, and you're showing me work, and you're about to tell me which number should I use, 2 or less. Point what?
138.
138. 138 plus point
392.
392. What was it? 392? 392 plus point
444.
444. There's the numbers for 2 or less. 2, 1, and 0. And you add them together. What was that? 339? Is that 8? Wait, what is that number? 392. There we go. You would add those together, and look, this question was 1 point. Quarter, 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 and quarter. This was a 1 point question, and there's your work. The numbers you used off it. But here's the deal. Someone may say, I want to do the opposite way. Matter of fact, they're going to say, watch what happens if this says 2 or more. Okay, 2 or more. What changes here? Right here and right here. On the Excel, this is 2 or more now. 2 or more equals 1 minus in the front. The opposite of 2 or more,
1.
1 or less. That stays the same, that stays the same, that stays the same. But now we're going to the table. We gotta use certain numbers that represent 2 or more, but we can go either direction. So there's 2 right answers here. So again, the 50% column, here's the 2 right there, 0.138. One person may say, I'm gonna take 0.138 plus 0.024 plus 0.002 plus 0, and there's 2 or more. But another person may say, whoops, I gotta make sure I'm in the right column. I'm gonna do the opposite of 2 or more and just find 1 or less and then subtract it from 100% or 1.0. So 2 or less, 1 or less would be what numbers? 0.392 plus 0.444, right? That's for 1 and 0, which would be the opposite of 2 or more. I add these up, let's see, 6, 13, 8.836, and I go 1 minus 0.836 equals the answer as if I would have added the other ones. See what I did? And you're still the same amount of points because you had to do this big extra step here. So whichever direction you go is the right answer.
Are you gonna be giving us like a word problem and then we have to take the numbers out?
Possibly, I don't know.
How about if it says that exactly one number?
Then you only have, yeah, that's the thing. If I'm asking you a question to use the table, I'm probably not gonna ask about just one number, because you really aren't showing me any work, you're just giving me the answer. You could have done it using Excel, you could have done it, solved it manually, you could have done it off the chart. I have no way of telling. The only way I can tell you using the table correctly is if I ask you a question for a number or more or a number or less, and you're gotta show me exactly which number you used off the table. That's the only way I can do it. So if there's a question about using the table on the quiz, it's probably gonna be an or more or less. So I can see that what numbers you're using. But you gotta download your own table, I'm not providing you with the table. So remember that, when you get in here, to have the tables ready to go. Yes?
Is this the table that's gonna be?
Yeah, that's the table, yeah. That's the one that's already posted on Blackboard right now, or on Canvas. Does anybody know what I mean when I said Blackboard?
Yeah.
You do? Because there's still colleges using Blackboard, and U of M used to use Blackboard many years ago before we switched to Canvas. Blackboard's just like Canvas, by the way. Just like it, it's just not as many functions, I guess.
Canvas works better.
I can't tell the difference. Other than the learning curve it took for me to learn Canvas after I knew Blackboard like the back of my hand. Man. All right. Any questions? You want to do another? Let's do. I have another one prepared. I have one out of the book. I'm going to read the problem. You guys tell me the three numbers here. Hang on, let me get them. Let me get ready. Figure out what numbers we're going to use off the table, and we got to put it into our Excel here. All right. Going right here. I'm on page 178 if you happen to have your book. I'm down at the bottom in example 5.8. Is it up there? Barely. Come on. Let's see if I make it bigger. I think I lost my pointer. Anybody see it anywhere?
Yeah, it's right there.
Where?
What's your point five?
I don't see it.
It's
I don't
up
see
by
it.
your menu bar.
Okay, I'm gonna use this. There's no pointer, you guys are making it up. It wasn't moving though. That's the point I guess I was moving. Okay, I'm gonna read this one right down here. Where's this pointer? There it is, right there. In the United States, about 30% of adults have 4-year college degrees. I can barely see this. I think, is there a way to make it get better? 30% of 4-year degrees. So suppose 5 adults are randomly selected. I'm gonna stop right there. There's our given percent. I'll put it here, 0.30, given. Then the next sentence said, suppose 5 adults are chosen at random. Is that my X or number of trials? Very good, that's the number of trials. Now we're going to a question, we're going to, I put on here A, or B, go to B. What is the probability that no more than 2 of the adults out of the 5 have college degrees? No more than 2. That's no more than 2 is the same as 2 or less?
Yes.
For sure? All right, here we go. 2 or less. Okay, let me start here with the Excel. Do I need the 1 minus?
No.
No, what's the first number here? 2, comma, what's the number of trials? 5, comma, what's,
10%.
not 10,
30%.
30%, 0.30, comma, 1 or a 0?
1.
1, because it's 2 or less. 2 or more, 2 or less, you gotta have a 1 on the end. There's our Excel. Now let's go to our table. Our table is how many trials? Our percentage is 30. We gotta figure out where, I gotta make this smaller again so we can figure out where the 30% is.
It's not 30.
Oh, thank you. Good call. Boom. Let's go over here. Hang on. We're doing it for, we will switch. Hang on. Okay. Here we go. For right now, it's for 2 or less. 2 or less. I'm going to the 30% column, which is this column right here. I'm going to count how many is that? 1, 2, 3, 4, 5, 6, 7 columns over, right? Is that the one we're doing? Yes. 7 columns. Now I'm going to scroll down to the 5 because we have 5 in our trial. There it is. 1, 2, 3, 4, 5, 6, 7. This is our column right here, just to the left of my pointer. Now, what numbers, you're showing me work, for 2 or less, what number should we use? Point.
0.309.
Oh, jeez. What the heck was that? I heard 168.360.309. Am I doing something wrong?
No.
Are those the real numbers?
No.
Well, come on, come on. Here's the column, right where the pointer is, to the left of the pointer, and this says 2 or less. So I grab the numbers for 168 is for 0, 360 is for 1, and 309 is for 2, correct? That's 2 or less. If I add them up, I got my answer, correct?
Yeah.
All right, now, you ready?
More.
2 or more. Stay with the table right now. I could do it 2 or more. And I'd have to add up the numbers for 2 or more. Let me grab them.
0.309.
309, 132, 028, 002, and add them up. But watch what I can do instead. The opposite of 2 or more would be 1 or less, which would include just 2 numbers. 360 and 168. So watch. Just cross out that 309. Now add those 2. All right, this equals then 1 minus whatever that is, equals the answer. You have the extra step of the 1 minus after you add those up. That's why it's worth as many points. My question is, what do I got to put here for 2 or more? A 1 minus in the front, and what about here?
1.
1 or less. The opposite of 2 or more. Opposite of 2 or more would be your first number out of more than. Okay, we've looked at a couple examples of how to use the table. We reviewed how to use Excel, both directions, whichever direction we're going to go, or on a more than especially. We got binomial down. We need to switch to Poisson. You ready? Let's go to Poisson. This table looks like this, if you recall. Let me get to the top. Let me make it bigger. The numbers across the top in big bold black are the mean, and then your x. And with Poisson, we only need 2 numbers. That's it. The number being asked about, the mean, maybe the mean has to be converted to be the same interval as what's being asked about, but the mean, and then a 0 or 1. So let me get rid of this. We're now gonna do Poisson. Number being asked about, here we go. Number being asked, the mean, those are the only 2 numbers we need. That's it, just 2 numbers. So let me we'll go to our first example, that same one off the PowerPoint. Faster. Okay. Patients arrive at an emergency room at Mercy Hospital at an average rate of 6 per hour. 6 per hour. So right now, the mean is 6 per hour. That's what it's at. We haven't converted it yet. We haven't decided we need to convert it. And if the question's in hours, we don't have to convert it. It says, what's the probability of 4 arrivals in 30 minutes? What's the probability of 4 per 30 minutes? The mean has to be about 30 minutes. Our first number's a 4 though. So equals, is this asking for 4 minutes or less, 4 minutes or more? Which Poisson should I use? The top one or the bottom one?
Top.
Top one, because this is asking for 4 minutes or less?
The number itself.
Then just 4, exactly, which is also the top one. We just gotta make sure you use the right number on the end. So this equals Poisson, parenthesis, this is asking about 4 per 30 minutes, then the mean, comma, this is asking for exactly 4, that's why there's a 0 on the end. Now let's talk about that mean. The mean's been given to us as an hour, but we have to convert it to 30 minutes. So if it's 4 per, or 6 per hour, what will it be then 30 minutes? Per 30 minutes, what will the mean be? There it is. It takes, you have to cut an hour in half to get to 30 minutes. If that's what you gotta do with the interval to cut it in half, that's what you have to do with the number and the mean is cut it in half. So our 2 numbers now are 4 and 3. Put a 3 there, we got the answer. Let's look at what this answer is. We're reviewing Poisson, so we'll go back here. Equals, P-O-I-S-S, there it is right there. Poisson dot D-I-S-T, or the other one, I'll use the dot D-I-S-T. X is what we're being asked about, in this case is a 4 4 arrivals in 30 minutes at the emergency room. How many do we usually get in 30 minutes? 3, comma. Is this asking about 4 or more, 4 or less? No, it's asking about 4 exactly. Put a 0 on the end. Okay, if we did this right, 0.168. 0.168, if we calculate it manually, 0.168. And if we use the chart, the table, we're gonna be going to where the mean is 3, go down to where it's asking about 4, and see if the probability, and if it's 168, we did it correctly. So let's go to the table, find 4. Well, this goes to 1 at the top. This one goes from 1.1 to 2. We gotta get all the way to 4. There's 4, right there. And then we're asking for how many out of 4? 3 out of 4, is that right? Where's 3? Is it 3?
1.465.
Hang on a minute, 3 out of 4. Oh, the mean is 3, my bad. There, the mean is 3, and we're asking about 4. There's 4, when usually there's 3, 0.168. 0.168, so the mean is the big numbers across the top, then you have all these other numbers. Now, let's keep looking at this. I'm changing this, here we go. I'm changing it to 4 per 30 minutes, 4 or less per 30 minutes, 4 or less per 30 minutes. Let's start with the Excel. Do I need to change the beginning here with a -1 in front?
No.
Do I change this number right here, 4? 3 is still good, so all we change is a 1 on the end. There's 4 or less, right there. Let's look at the Excel answer real quick. All I'm gonna do is change that 1 number, whoops, on the end, from a 0 to a 1. 0.815. Now let's go to the table and see if we get the same answer. The mean is 3. The question's about 4 or less. You're gonna show me work for 4 or less. Now look at how many numbers are involved. 0.1680 plus, I'm going 4 or less. 0.2240, is that correct? 0.2240 again. This is 4, this is 3, this is 2. Now for 1 is 0.1494, and then for 0 is 0.0498. I would add those all up, and that's the answer for 4 or less, when usually there's 3 arrivals in the emergency room, using the table. Here's my work. Here's the numbers I used off the table, and the sum of them is my work. All right, this is worth more than 1 point even. Yeah. Quarter, there's 1.5 points. Question, right? 1 or more, I'm sorry, not 1 or more. 4 or more, let me do this, hang on, 4 or more. Let's do the Excel first. Right here at the beginning, we gotta put a 1 minus in front, so equals 1 minus Poisson. The first number is supposed to be the opposite of 4 or more, so I gotta change it now to a 3 or less. And a 1 stays on the end. The mean stays. I put a 1 minus in front, put it the opposite of 4 or more. And now I'm gonna look at the table. 4 or more, well, I have a lot of numbers to add up, because right now the pointer's right next to the 4. I'd have to add up 0.1680, 0.1008, 0.0504, 0.0216, and all the way down to the bottom. Or I can do the opposite of 4 or more and subtract from 1, which would be 3 or less. So I'm moving this up to 3 or less. 0.2240, 0.2240. The only number I take off is that 0.1680. 0.2240, 0.2240, 0.1494, 0.0498. I add those all up, and whatever that equals, 1 minus that number equals our answer. Whatever those add up to, I can subtract from 1. I added up the opposite of 4 or more, for 3 or less.
I thought if you do the opposite, you don't have to subtract from it.
No, if this is a 4 or more, you can do the opposite, which would be 3 or less, and subtract from 1. And just like Excel, just like this, but you don't have to. I could have done 4 or more this way. I could have added 4, 5, 6, 7, 8, 9, 10, 11, 12. I could have added all of those instead and not subtract from 1. But instead I went the opposite direction, and that's why I'm subtracting from 1. Can we all remember now how to use a Poisson table and how to use Poisson Excel? Yes, yes, yes? Okay, now the new Excel that we have. Let's get to that. This, what, you had a question?
I thought this was the new stuff.
Oh, no, this, it is the table part. No, that was all review. We did Poisson table even. This is kind of review right here. Remember that, I remember I talked about this RANDBETWEEN as a way to randomly select. Here's the story, if you remember. This is from like 3 or 4 weeks ago. We were in admissions. We were supposed to go to a meeting. We had 900 admissions applications, but we haven't got time to figure out what the average SAT score is or what percent said they want to live in the dorm. So instead we did a random sample, and there was 900 of them, right? 900? Yeah. And so we needed to number them all from 1 to 900 so we could pick 30 of them out. But we wanted to come up with a way to where all 900 had an even chance to maybe be selected as one of the 30. So here's the deal. Every time I change a cell, any cell on the spreadsheet, the word random tells Excel to find a new number, a random number. So watch this 892 will then switch to, here's the first one we're gonna pull out. I'm putting a space here. We're now pulling out 182. I'm gonna put a space here. We're now pulling out number 530. So here's 132, here's 530, hang on, I'm gonna put a space. Any change I make on this spreadsheet will change this number. 848 is the next one we're pulling out. 726. RANDBETWEEN, if you look at that, the way it's written, RANDBETWEEN is used with discrete data. 1, 2, 3, 4, 5, 6, with no numbers between the numbers. That's when this one's used. Now I want you to see this in real life. So I found an old simulation. Remember me talking about how businesses are all about doing simulation when they're about to spend millions of dollars to try to figure out in advance using randomness, whether they're gonna, what the odds are of making a profit or not making a profit? Well, here's one right here. And as you can see, here's all the things that they're not sure about, but they gotta kind of estimate. Market size in units. They're saying, hey, when we first start out, what will be our market size? Will we sell, marketing came to the meeting and said the least amount we'll sell is 100,000 units. We could do as well as 350,000 units. Market share, hey, we're gonna be grabbing about 3% of the market share or 17%, somewhere in between, we don't know for sure. Here is total investment. This total investment to get started in this business we're about to go into could cost somewhere around 7 million, but if things don't go right, it could cost as much as 10.5 million. These are all the unknowns. This is how it works in the real world. You come up with all the things that you're just not sure about if we do this expansion and spend the $7 to $10 million or not. And we then say, but we can come up with logically around what it could be, a range. This next one, useful life. The equipment we have to spend money on to do this new product will only last somewhere between 6 and 15 years, and we're not sure. So we're gonna simulate it only lasting 6 years. We're gonna simulate it only lasting 15 years, and we're gonna simulate everything between there. That's the whole point of simulation, is you simulate all the possibilities that could happen if you go with this venture you're thinking about going into. So let me show you where, I'm trying to think what would be discrete and what would be continuous. So let me jump down here. Here we go, useful life. Okay, the useful life on this simulation is the simulation decided that we're only going with whole years. Either the equipment's gonna last 6 years, 7 years, 8 years, 9, 10, 11, 12, 13, 14, or 15. Nothing between those numbers. So the simulation for that useful life is right down here, and look at how it's written. Equals RANDBETWEEN, parentheses, 6, 15. It's telling Excel, pick a number for the useful life between 6 and 15 years, and use RANDBETWEEN, which means it's gonna come back with a discrete number. 6, 7, 8, 9, 10. Never will it say 6.5 years, or 7.2 years, or some weird number. That's when RANDBETWEEN's used. So there it is right there. Look at the next one. The next simulation, we're gonna pretend as if the machine lasts 12 years. This one, 14 years. This one, another 14 years. 13, 10, 10, 9. When you simulate, all the work is in that first row, putting together all these RANDBETWEEN formulas and adding and subtracting. Then you copy and paste for 999 cells below it. 999 rows below it. And that's how simulations work. You want to simulate 1,000 different possible ways of useful life, of market share, of revenue, of expenses, every possibility, and then figure out whether you're going to make a profit or not on doing this venture, or what is the probability of making a profit or not. Okay, now I want to teach you the other one and then go back to the simulation. Here's the other one, RAND, parenthesis, parenthesis. This one's used with continuous data. This one's used when you want the result to be numbers between the numbers.
There's no equal sign?
I'm sorry?
There's no equal sign?
There is. I'm just showing you, hang on, I'm gonna show you how it's written. Ready? Hang on, I gotta scroll down. Here we go. Here's an example of just RAND, parenthesis, with an equal sign in front. When it has an equal sign in front, it's gonna bring back a number between 0 and 1. Did everybody hear that? It brings back a number between 0 and 1, and how you use it is you'll bring back that random number and multiply it times something. So it'll always be part of a number. Maybe it came back with 0.50 times 10. Well, 50% of 10 is 5. Maybe it came back with 0.25 times 6. A quarter of 6 is, 2 or whatever it is, 2, 4, 6, 2, 4, whatever it is, 2, 4, 6, 8, right? Quarter of 8 is 6, 2. So here is an example how it's used in simulation. Let's say manufacturing came back and said, hey, the cost for materials is going to be between $45.10 and $62.30. We don't know exactly how much cost for materials. It'll be somewhere in there. So in our simulation, we want to randomly have a low cost material somewhere around $45.10. We want to have a random high cost material somewhere around $62.30, and everything between there too. We want to simulate. So when you use RAND, parenthesis, with numbers like this, 45 equals 45.1, $45.10, plus RAND, parenthesis. Now that's selecting a number between 1 and 0, 0.5, 0.33, 0.67, whatever. Parenthesis, 62.30 minus 45.10. The range of the dollar amount above 45.10 it can go up to. And that range gets multiplied by the random number and added to 45. Now watch what's going to happen. Every time I hit and want this to change numbers, right now it's at 52.56, every time I randomize this, it will be a number between 45.10 and 62.30 every time. So now we're going to do another trial. Materials was 52.56. What's it going to be now? 61.22. Now we're on the high end of materials. Let's see what effect this has on over however many years useful life is for this business. Let's do it again now. Now it's at $50.95. Okay, that's more in the middle, closer to 45 maybe than 62, but it's more in the middle. Let's try another one. Now it's at $53.26. That's almost right in the middle. That simulation is going to simulate materials at $53.26. Let's do another one. Here we go. Now we're much closer to a really great price of materials. We're probably going to make profit on this simulation because our materials are at $46.66, darn close to the lowest we thought it could get to. And that's how RAND, parenthesis, works. Now let's go back to the full simulation, and I want to show you an example. Market size. Whoops, what's going on? Oh, there it is. Look at how it's being used in this case. RAND, parenthesis, times D3 minus C3. Let's see what D3 minus C3 is. And it has to do with market size. Okay, D3, whoops, way up here. D3 has market size at 350,000. C3 has market size at 100,000. So if you subtract the two, market size has a range of about 250,000. Somewhere between 100 and 350,000. Now watch when we wrote that equation, it's going to take the range between there, multiply it times the random number between 0 and 1, and then add it to the lower number, the smaller number. What was the smaller number, 100,000? The 100,000. So here in the first simulation, excuse me, the first simulation is at, now I gotta make it bigger, you can hardly see. $336,820. The second simulation between 100 and, now it's at 103,518.57. As you can see, we can have partial tons. This is our market size in tons. And every number is between 100,000 and 350. Go another one. 315, 168, 252, 200, 199, 320. That's how randomness works. Look at total investment required. Somewhere between 7 and 10.5 million. We're using RAND and parentheses instead of RANDBETWEEN, so it's going to give us pennies. The first simulation says we're going to spend $9,642,497.63. The next one says we're spending 7.6 million. The next one is a little over 10 million. But that's how. Now here's the deal in real business. You jump into the end of this simulation. Look at what this simulation says. The first one says, okay, however long that machine lasts and however long you're going to do this business, based on randomness of all the ranges you gave, you are going to make around $31,276,578. And right now everyone's going, we got to do this. We can make 31 million, but look at the simulation below it. It says we're going to lose 6,608,000. Our expenses were probably higher on that next simulation. Our revenue must have been lower on that randomness of the next simulation. Look at the one below that. We're going to lose 9,469,000. You run this simulation several times and you get the accumulation of that last column. How many times will we make a profit? How many times will we lose a profit and turn it into a percentage? Let me show you here. Here's what we really talk about. You ready? Hang on, watch these numbers change. Right now it's at 5,214 and 31 million. Watch this. There we go. I did a whole nother simulation. The least amount of profit we can make is 253,000 if we go forward. The most amount of profit we can make is 45 million if we go forward. But we could have a loss, and the lowest loss we could have is a loss of 258,000, but the worst loss we could have is a loss of almost $19 million. Do you see what's showing us here? Over here, what percent chance, according to the simulation, how many out of 1,000, or what percent out of 1,000 showed we'd make a profit? 63%. What percent out of all of 1,000 said we're gonna make a loss? 37%. You're sitting at the table. You're one of the executives who make the decision now. Do we spend the 7 to 10.5 million, right? Do we spend the 7 to 10.5 million with these odds? No. Matter of fact, I don't know. I've never been in a company that would do it at these odds. Even though we have more than a 50% chance to make a profit, that is far too much risk to lose millions of dollars. 37%. Most companies, many companies will say, look, this simulation's got to say that we only have about a 10% or less chance of losing money, or we're not going to spend the money. We're not going forward. And what companies will do is once they run the simulation and they see such a high percent chance of losing money, 37% like that, they say either we forget about this, we're not going forward with this new product, or we all go back to the drawing board to figure out how we can cut expenses. The foreman of manufacturing says, I'm going to go and talk to the union. Maybe we can get a special deal for this new line that we're going to develop to make this product with the union and get our labor costs down. Someone else who works in procurement, that's a division of a big manufacturing company. Procurement is somebody who's a buyer. All right, anybody ever heard of this? These are the people that have the cake jobs because they're the ones that get to negotiate buying things from the suppliers. And being the one that spends hundreds of thousands of dollars with the suppliers love you and they send you Christmas gifts, which is not supposed to be done, by the way. That's kind of trying to be favoritism. So don't accept that Christmas gift. When it shows up at your door, send it back to the supplier. You hear me? All right. But you're the one who's now calling the suppliers and say, hey, what if I bought more? What if I bought 100,000 pounds instead of only 10,000 pounds? What kind of price can you give me then in that case? You start renegotiating things, and then you change your numbers on the simulation to what you renegotiate at, and you run it again. And you say, okay, did we get that down to 10%? And if so, because you made these renegotiations, now you're talking about going forward. That's how you lower the risk of going bankrupt. And that's what big companies do. They simulate things before making the big decision. So they avoid going bankrupt, especially when there's shareholders involved who don't want to lose their money. Anyway, that's how this is used in real life, guys. If you think you're an accounting major, any accounting majors here? Yeah, you're kind of responsible for putting the simulation together, accounting majors. So you're the finance person. You're the one who's heading up this meeting, helping make this main decision. So know that this is in your life in the future if you decide to become a corporate controller or head of an accounting department in some way. If it's a big company, you got to help put this meeting together. You're the head of this meeting. Any questions about randomness? Let me see. There's our original. How to use RAND, parentheses. Last is SQRT. All this does is find the square root of something. Equals SQRT 2,356. The square root of 2,356 is 48.53864. SQRT just finds the square root of a number, but we have formulas where you are going to have to use SQRT in the Excel equation itself. So I wanted to make sure you have that function and you knew how to use it. That's all I've got, except for one thing. I'm going to stop the video. Any questions about what you've learned about the new Excel? Go ahead.
Is it always the equation for RAND?
Where? Say that again. Right here?
Yeah, is that always the equation?
No. This could be done so many different ways. I just wanted to give you an example of how RAND, parentheses, is being used. There are so many different ways. There's like a million different ways how to use that. So many different equations. I just wanted to show you a common one. A common one to find something between two numbers. Oh, don't back up. We got something to talk about. Wait a minute. We got something to talk about. Let me show. Go ahead.
How did you know with the 45.1 plus?
Yeah, the only reason I used those $45.10 and $62.30 was hypothetically, if we were at a meeting and manufacturing said, hey, I think the cost of materials from all the phone calls I've made or the cost of labor is going to be between $45.10. From discussions, you'll get this range and then you apply the equation. Everybody hear that? It's from discussions with those who are experts, everybody working at the company who has expertise in each of those areas. Somebody who manages labor, they're the ones who are going to be able to figure out what the cost is. Like the example I used last time was golf bags. Hey, we're a golf company, we're going to make golf bags. A golf company will buy some of the materials and literally say, okay, pull some people off the line who aren't busy and say, come on, let's make some golf bags. I want to see how long it takes. And they're saying, let's, here's how to do it. Let's do another one now. Let's do another one. Okay, now we got it like where we know what we're doing. We can see how long it takes. They're timing it, and they can come up with labor costs then for each golf bag. This is how it's done in real world. And they're coming to the meeting and go, okay, we made 5 golf bags. When we got to the 5th one, we had a routine down. We think it will take this long. Here's the cost of labor for that golf bag. That's how it works. Material. Person in procurement's been calling all these suppliers, trying to figure out what the cost of material. They know exactly how that golf bag can be made and every piece of material involved. And then they buy some of the material so that manufacturing can make a few of them to figure out how long it will take to make them. That's how it works.